Right, good morning again. Apologies for the live lesson earlier. Some technical issues that I found very difficult to overcome because I haven't got a clue most of the time. Um, the sharing of the PowerPoint was my fault. I thought I'd done all the training and I'd missed that bit. I just thought you had to open it up and you actually have to press a particular share. And the control taken over by other people was not my fault. I don't know what was going on there, but I believe that technical issue will be sorted for next week's live lesson, which hopefully we'll get right. Okay, so this is the starter of the hook. We said there are two kettles, one with a power rating of 1 kilowatt and one with a power rating of 2 kilowatts. Which one would transfer or heat up the kettle quicker? And of course, it's the 2 kilowatt kettle because it's transferring twice the energy um, into the water in the kettle, assuming, of course, it's the same amount of water in each kettle. Okay, so that will make it boil fastest. Okay, so we're on to the power equation. Some of you have probably gone through this a few times now. Repeating what's going on isn't the end of the world. So let's have a quick look at it. So this equation links energy transferred with power and time. Okay, so there's the formula, and you can see energy transferred. Energy is in joules, power is in watts, and time is in seconds. And you must make sure when you're doing your calculations that that is the case. What I've done underneath is shown the different rearrangements of the formula. So E equals P times T as above. If you want to time, then you need to divide energy by power. And if you want to power, you divide energy by time. Okay, so underneath is a COD example of the sort of question that you might get on this really basic energy transferred equals power divided times by time. So a lawnmower engine transfers 10,000 joules of energy in 10 seconds. What is the power of the engine? So first of all, okay, we've got E equals P times T. And what you do is you put in your numbers that you already have. In this case, we already have the energy transferred and the time in seconds, but we do not have power. So you need to find the rearranged equation. You rewrite out the equation so that you isolate the power, and then you do the calculation. You'll find out that it's 1,000 watts. Now we can also write 1,000 watts as 1 kilowatt. So like kilometers, 1,000 watts is a kilowatt. 1,000 meters is a kilometer. Okay, and look out for that, and I'll give you some tips on that as we go along during this lesson. Okay, so here we are now looking at what is power. Well, power is the amount of energy transferred in a second. So if a device, an electrical device, has a power rating of 100 watts, it's quite a low power rating actually. A washing machine will have something like 2,000 watts, a kettle 1,500 watts, something like that. Means the 100 joules of energy is transferred every second. Now, a joule of energy is the energy required to change the temperature of 1 milliliter of water by 1 degree centigrade. So it's actually quite a small amount of energy. Give an example of this. If you had a litre of water, 1,000 milliliters, and you change the temperature by 1 degree, that would take 1,000 joules of energy. It's a lot of energy, a lot of joules. So here's a really simple example here. Calculate the power, okay, when joules of energy is transferred, 2,000 joules of energy is transferred in 10 seconds. Okay, so on this case, power equals, so isolating power equals energy divided by time. So it's 2,000 divided by 10. So the device that we're looking at here has a power rating of 200 watts. Okay, moving on to the next slide. We've just got some tips that I've touched on already regarding how to make sure you get the best out of your calculations and be as accurate as possible. I don't need to remind you that actually writing out your working is really important. It helps you to see if you've made mistakes where they are, okay, and it also helps examiners and your teachers to see how you're getting on, how your thinking is going, and if anywhere highlight and be able to identify any problems with your calculations. So first of all, tip: check your units. Okay, in the case of as I said earlier, in terms of kilowatts, for example, that's 1,000 watts. So before you do any calculations, make sure you convert it into um, the, the units that are required for that particular formula. Okay, and secondly, things like time, really important. Quite often examiners will try and catch you out by saying minutes or hours even. Make sure you convert those into seconds before you add them into your calculations. You might even do that as a first step in your working. And the second one is write out the equation first, transfer the numbers in, substitute the numbers that you have, and then identify the thing you're looking for, okay, and then rearrange the equation, okay, as you would do in maths. So energy equals power times time. If you've already got the energy, 20,000 in this case, equals power times 10. So you need to isolate power, so it'll become 20,000 divided by 10, and the answer would be 2,000 watts. Now you can convert, for example, that into 2 kilowatts. Okay, examiner, examiners tend to accept either way, but only transfer into that simpler form if you're absolutely confident you know what to do. Right, on to the next slide. These are some practice questions. They're all pretty straightforward, using the formula that we already have looked at for energy transferred equals power times time. The first two are really straightforward, just to get you back into the swing of things. The third one, number 3, has slight changes. Just look at the time bit, be careful with that. And the fourth one, just look at the power value there as well. So you just need to convert that before you calculate. I'm going to give you a couple of minutes, maybe 5 minutes or so, to complete those calculations. So at this moment, if you'd like to pause the lesson. Okay, welcome back. Hopefully you've had a go at calculating those. And let's just quickly go through the answers. Number 1 was straightforward multiplication, and so was number 2. I've made a little bit of a mistake there because the joules should be as a capital J, not a lowercase. Okay, the third one, you need to calculate how many seconds in a minute before doing the multiplication. So it's 120 times 0.04, which is 4.8 joules. And finally, 3 kilowatts is a 3,000 watts. Okay, for 30 seconds would get you 90,000 joules of energy. And I've converted the answer into kilojoules. Okay, so on to the next calculation, which is to do with electrical resistance. Now, all electrical current when flowing through a wire has some resistance against it, something to try and stop it. The electrons are bumping into particles, and they're actually being, resisted. And that resistance does produce heat energy. So you may have noticed over time, if you're charging your phone, the charging cable or even the phone itself may have got a bit warm, and that's the transfer of heat energy because of resistance. The metal used in wires in the home or anywhere else have got low resistance. It makes sense too because it's energy efficient. Okay, but they all have different resistances. Okay, and things that hardly allow electricity through have got high resistance. Okay, resistance is measured in ohms, OHMS, and the symbol is that little sort of head and shoulder symbol that you can see in the calculation. So voltage equals current times resistance, and we typically write it as V equals I times R. V is voltage, R is resistance, but I is current. It's the universal letter for current measured in amps. Okay, so let's have a look at a couple of COD examples of this. We've got a current thrown through a wire. It's 0.5 amps when the voltage potential difference is 4 volts. Calculate the resistance. So we need to do a quick rearrangement of the equation there. So to find the resistance, you need to divide the voltage by the current. Okay, and that will give you a value of 8 ohms. And the second one is current through a torch bulb is 0.015 amps, and the potential difference voltage is 12 volts. And so we can do the same calculation again, and the answer there would be 800. So now this next slide looks at how we can apply power to this. So if you think about this, V equals IR. Okay, power equals I times V. Okay, so If you replace the V in the equation with I times R, okay, and rewrite it, you've got power equals I times R. And I times I is I squared. So when you introduce power, it's power in watts equals current squared in amps and resistance in ohms. Okay, so this is the next equation that you will need to have an understanding of and working knowledge of and use for your homework. Okay, and we can write it in the simplified version as P equals I squared times R. And that just shows you that power is proportional to the square of the current. So if we double the current, we quadruple times 4 the power. And that link, that inverse squaring is quite common in science with all sorts of different parts. So we're going to look at now a worked example of this. It goes, the calculations go on for 3 slides, but you only need to copy down the main bit in the first slide. So electric popcorn maker has a power of 1500 watts. It has a resistance of 35.3 ohms. What's the current during use? So we know we've already got power, we've got resistance, so we need to find current. So let's first of all write out the equation. Power equals current squared times resistance. And as explained earlier, add in your values that you already have. So it becomes 1500 equals I squared times 35.3. So the next step is, of course, to, we've already got that written out. Okay, so we need to rearrange the formula so that the thing that we're looking for in this case is current is on one side of the equation. So it's current equals power divided by resistance. But at this point, you still don't need to do the calculation because or you will in a second, but there is one more step. Okay, so we've got to this point where it's current squared equals 1500 divided by 35.3. And then what we do is do the calculation. So it's 42.49, but that's only I squared. So we need to find the square root of 42.49. This is where calculators come in very handy. And you will find, if you work through, that the answer is 6.52 amps. And some final examples. So the first question is about the units of power. These are units that we use in electricity and in the calculations we looked at today. Very important. What are the 3 calculations for power that we would require? And also there are some nice examples. So heating element to 12 volt heater was a resistance of 40 ohms, the current of 0.38. When it's connected to a 12 volt motor supply, calculate the power supplied to it and the energy transferred in the heating element by electric current in 20 minutes. Okay, have a go at those. I know not all of it's easy. And at the end, just go through the answers. Okay, so the units are watts, joules, volts, amps, coulombs, and ohms. The equations used to calculate power are these. Okay, power supplied is 36 watts in this case, and 43,200 joules, or 43.2 kilojoules in that. So your homework is going to be set by your teacher and show my homework. The link to this PowerPoint as well is there, so you can work through your work. Please submit your homeworks to your class teacher. There is an extension piece of work for those people who feel confident about calculations. And I look forward to hopefully seeing you live and without interruption next week. Take care.